Hi, so in this video, I want to show you how we can use velocity vectors to model the speed and distance. So if we look at the velocity vector in question A, we have 3i minus 4j. Well, this means that we start at a point, we go 3 across in the I direction, and then 4 down in the j direction. So we're going from here to here, and we're traveling in this direction every second, so meters per second. Okay, so this is a velocity vector because it has a direction and a velocity. So the direction is we're going in this diagonal. The magnitude of this vector is its speed. A speed has no direction. It is a scalar quantity. It tells you how fast you are going, but in any direction. So the magnitude of this, well, this would be the 3i, and this would be the minus 4j, or just 4. So the magnitude would be the Pythagoras theorem. We have it as a right-angled triangle. So this will be the square root of 3 squared plus 4 squared. So this will be 5. So in terms of the speed, it would be 5 meters per second, but as a velocity vector, 5 meters per second in this direction. Okay, so now we know the speed, we can work out the distance. If we're traveling at 5 meters per second, and we're traveling for 10 seconds, we multiply this by 10, the seconds and this will cancel, so we're left with 50 meters. So this is how you can work out a speed and a distance from a velocity vector. Okay, let's try question B. So we're starting at a point, we're going 5 in the I direction, and then 12 in the j direction. So our speed is the magnitude of this hypotenuse. So 5i and 12j. And this magnitude is for speed. And we can work this out using Pythagoras' theorem again. So 5 squared plus 12 squared, the square root of 169. So the speed is 13 meters per second. And the distance, well, we're traveling at 13 meters per second for 15 seconds. The seconds and the inverse will cancel. So we're traveling 195 meters. Okay, so do you want to try and work out the speed and the distance for the velocity vector in question C? You can pause the video, and when you come back, we'll go through the word solution. Okay, so for question C, we're starting at a point, we're traveling 6 in the I direction to the left, and then 8 down in the j direction. So this is our direction here. The magnitude, the speed, we can use Pythagoras' theorem to work out the magnitude of this line. So that will be the square root of 6 squared plus 8 squared. The square root of 100. So this will be 10 kilometers per hour. And because we're traveling for 2 hours, it's over 2 lots of 10 kilometers, so 20 kilometers in 2 hours. Okay, let's try the next question. Okay, so now we've got an exam style question. The velocity v of a particle, p, at time t seconds is given by the velocity 1 minus 2ti plus 3t minus 3j. And we've been asked to work out the speed of p when t equals 0. So to make this simpler, I'm going to write it as a column vector, where v is equal to 1 minus 2t, and then 3t minus 3. And for part A, we're told that the speed of p when t equals 0. So if we substitute that t equals 0 into our vector, we have 1 minus 2 lots of 0, and then 3 lots of 0 minus 3. So we have 1 minus 3, so 1i minus 3j. So the speed, we're moving 1 in the I direction, minus 3 in the j direction. So we're looking at the length of this vector here, where we have 1 and 3. So it'll be the square root of 1 squared plus 3 squared, square root of 10. So this will be the initial velocity when t equals 0, root 10 meters per second. Okay, for part B, okay, so when t is equal to 2, we can work out our velocity vector, which will be 1 minus 4, and then 6 minus 3. So all I've done, I've substituted t equals 2 into each of these. So now we have minus 3 and 3. So our direction, we're moving minus 3 in the I, positive 3 in the j. So we're traveling in this direction. But to work out the bearing, we need to draw a north line. And the bearing is 3 digits going clockwise from north. So what we need to do is to work out this angle. And then from this angle, we'll add it on to 270. We could have worked out this angle and then subtracted that from 360. It doesn't matter. We know this is 3, and we know this is 3. So we can use trigonometry. So tan theta will be the opposite of the adjacent. So theta will be the arctan of this. So theta is 45 degrees, which means the bearing will be 270 plus the 45, so 315 degrees. Okay, so for part C, find the value of t when p is moving parallel to j. So if it's moving parallel to j, then we know it is moving either up or down, but it is not moving across. So if we look back at this vector, we have 1 minus 2t, and then 3t minus 3. This is our velocity vector. We know that the I component is 0, because it's only moving up or down parallel to j. So now we have an equation where 1 minus 2t equals 0. We can solve to work out t, so 1 will equal 2t, t will equal 1/2. So after 1/2 of a second, we are traveling parallel to the j-axis. Okay, so do you want to try this question? You can pause the video, and when you come back, we'll go through the work solution. Okay, so for question C, part 2, we're told that the vector 1 minus 2t and then 3t minus 3 is moving parallel to minus I minus 3j. So this will be some scalar quantity of minus 1 and minus 3. So now we can equate the I terms. So 1 minus 2t will equal minus lambda. So we have multiplied this out here. And then 3t minus 3 will equal minus 3 lambda. I'm going to divide this equation by 3. So we have t minus 1 will equal minus lambda. So now I'm going to substitute this value of minus lambda into our first equation. So 1 minus 2t will equal t minus 1. We'll move these negative 2t's to the other side. So 1 will equal 3t minus 1. We'll move this negative 1 to the other side. So 2 will equal 3t. Divide both sides by 3. And t will equal 2/3. Okay, let's try one more question. Okay, so in this question, we're told that a particle is acted upon by two forces, F1 and F2, and they are given by I minus 3j and pi plus 2pj, where p is a positive constant. And the resultant of F1 and F2, so the resultant is when we add the two forces together. And this is Fr. And we're given that Fr is parallel to I, which means it travels in the I direction, so left or right. And we've been asked to work out the value of P. So the first thing we're going to do is we're going to work out the vector Fr, which is F1 plus F2. And to do this, we'll use column vectors. So for F1, we have 1 and minus 3, plus F2, which is P, and then 2P. And this is parallel to I, which means it has some scalar quantity of 1, 0. So 1 in the I direction and 0 in the J direction. Now we don't need to worry about the I component because we can work out the P component from the J direction. So minus 3 plus 2P will equal 0 lambda, or just 0. So 2P will equal 3, which means P will be 3 over 2. Okay, thank you for watching and I hope you found that useful. Thanks again and take care.